Welcome to the Unique One tutorial. Today we are going to look at mathematical induction. Mathematical induction involves three steps. The first step is verification. In this step, we have to show that Pn is true when n is equals to 1. Step 2 is known as induction. It has two stages. The first stage is to assume that the statement is true when n is equal to k. The second stage is to prove that it is also true when n is equal to k plus 1. The third step is conclusion. We conclude that since step 1 and 2 hold, then the statement is true for all positive integers which belongs to n. Now, example 1. Prove by mathematical induction that 2 plus 4 plus 6 plus dash 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 plus 2n is equal to n bracket n plus 1. To solve this, we start with the first step. Step 1, verification. You say when n is equal to 1, you substitute this in this equation. Therefore, 2 times 1 is equal to 1. 1 plus 1. This implies that 2 is equal to 2. Since both sides are equal, we say the statement is true for n is equal to 1. Now we have proved step 1. We now move to step 2, which is induction. In induction, the first stage is we assume that the statement is true when n is equal to k. We now bring down the equation. Pk have 2 plus 4 plus 6 plus dash dash plus 2k is equal to k bracket k plus 1. We name this equation 1. You see that just when you see n, you put k. Then we also, as we now move to the second stage, to prove that it is true for n is equal to k plus 1. We bring down the equation. Pk plus 1 have 2 plus 4 plus 6 plus dash 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 plus 2. You put now k plus 1 is equal to k plus 1 bracket k plus 1 plus 1. This becomes equation 2. From here now, we have to use the left hand side. The left hand side. We arrange it. We have 2k plus 2. Now, to prove, we add both sides of equation 1 by 2k plus 2. So we are going to add 2k plus 2 to both sides of equation 1. This is equation 1. Now, we now substitute our value. So this becomes 2k plus, you add the 2k plus 2. 2k plus 2 is equal to k bracket k plus 1. You add 2k plus 2. This becomes equation 3. So we are going to use the right hand side. We are going to use the right hand side of equation 3 to get the right hand side of equation 2. That is how we prove it. So it's using the right hand side of equation 3 to get the right hand side of equation 2. Let's proceed. We have k bracket k plus 1 plus 2k plus 2. This implies we have this times this is a k squared times this, we have k plus 2k plus 2. Now we have to add, we have k squared. We can factor out this. To factor out this, k is common, like just do it like this. Okay, so k is common, put k out, plus 1 plus, what is common here? We have 2, then k plus 1. So the factor out that we have k plus 1 and k plus 2. So if you arrange this, we are going to arrange this to get the right hand side of equation 2. This is the same thing as k plus 1 bracket k plus 1 plus 1. You see that we have gotten the right hand side of equation 2. So it holds. We have proved it. Now we now move to the next step, which is the conclusion. We say since the statement is true for n is equal to 1, also for n is equal to k and n is equal to k plus 1, the statement is true for all positive integers of n. This is our conclusion. So we have solved it. This is how to solve mathematical induction. It's very simple. The first step you verify when n is equals to 1. Then after that you move to the second step, which is you try to show when n is equals to k. We assume. After you assume, you have to prove that it is also true for n is equals to k plus 1. Then remember, what we are solving here is just to get the right hand side of equation 2. Once you get it, that is the solution. It has been proved. So thank you for watching. Don't forget to subscribe to my YouTube channel. You're welcome.